Hello everyone. Thanks for being here today. Let me just set the stage for what we're going to talk about. Dimitri's already done that a little bit, but my assumption about all of you who are attending, I know this isn't 100% accurate, but is basically that you guys are some kind of .NET developer, C#, maybe VB or something like that, and maybe you've played with Python, but you haven't really dug deeply into it. So what we're going to do is we're going to start out by just looking at the basics of the Python language, just enough so that you can understand the code that follows, the interesting parts. Okay, so we'll take like 5 minutes and talk about the Python language, and then we'll move on to all the cool features of Python, sort of viewed through the lens of a .NET developer. All right, so what we're going to do is we're going to look at all the things, excuse me, that are amazing about .NET and C#, things that maybe we think are actually unique to .NET and C#, and are the reasons why we chose and continue to use that language as at least one of the languages we use to develop software. What we'll see is most of the things that you would put in that list are actually very richly supported in Python, and sometimes even better than .NET. Sometimes not quite as much, but still in quite a good way. So that's the agenda for today. So I said I'd give you a quick high-level overview of Python. So Python is a high-level programming language. Probably you'd consider it a little more high-level than C#, but sort of on par with those languages. You'll often hear the term that Python comes with batteries included. So as you dig into the Python world, you'll hear this over and over, and what they mean is basically sort of twofold. One, Python has a large standard library, like .NET's base class library, that many of the things you need to do, the algorithms are right there for you. Web requests, regular expressions, all that kind of stuff, right there. It's typically an interpreted language when you use the default implementation, but there's also several very interesting JIT compiled versions as well. The most notable one being PyPy. We'll talk about that later. It's highly object-oriented, especially Python 3. There's Python 2 and Python 3 are sort of the two working versions these days. In Python 3, the language has been cleaned up to make OO stuff a little bit more consistent, let's say. It's strongly typed with dynamic semantics. So Python is a dynamic language. We often think dynamic equals untyped, kind of like JavaScript or something like that. That's not true for Python. Types are very strongly typed. Variables, not so much. The way you interact with them can be much more dynamic, but they're actually there's a very rich type system. The semantics of Python is really designed around readability, and you will see that as we do a lot of compare and contrast. And there's ways to sort of share and exchange and package up chunks of code into modules and packages and share them, very much like assemblies. Okay, so the biggest difference that you'll notice coming from a C-based language into Python would be the sort of the shape, the way that you define blocks of code and so on. So in Python, they've made a very different trade-off than they do in like C and JavaScript and C# and so on, in that white space matters. So the way that you actually define blocks of code is through indentation. So here you can see we've got a method, it's got a block in here, and we've got a print statement in this if here, and then we've got two print statements in the else. There's no curly braces, there's just indentation. Now that might seem tedious to manage, but you'll see when we work with the editors, especially PyCharm, that it very much manages this for us. So it's not actually nearly as difficult. And after a while, you'll probably prefer this. You very well may. So just to make sure we're all on the same page, let's switch over here to PyCharm. Now, there's many IDEs we can choose for Python, and a lot of people just go with Emacs or Vim or Sublime Text or something like that. I personally like PyCharm. I think coming from a Visual Studio background, PyCharm is just absolutely excellent, and I'm not saying that because I'm on this webcast with the PyCharm guys. Like, I really chose PyCharm on its merits, and that's sort of how Dimitri and I got connected in the first place, not the other way around. So let's go over here, and we're going to start by creating. Let me try to organize this into folders for you. So we'll have maybe I can have a language section. I'm going to put an underscore as the first character in case we need to import it. I can't really import things, modules, if there's a number as the first one. So let's go and create a Python file here. and I'll just call this, let's call this weather. So what we're going to do is create like a little super simple weather application, and I don't really need my name here. You guys know who I am by now. Okay, so what we want to do is I just want to write a really short application that has a couple of methods and things like that. And what we're going to do is just sort of get a list of the days and randomly assign some weather to them. Although for most of the country, most of the northern hemisphere, we could say cold is pretty much the weather. But let's go ahead and do it. So what I want to do is first I want to have a main method. So as you saw before, we define methods just like this. Here's our main, and we're going to call some functions. So the first one I want to do is say I'm going to define a variable, and in Python you don't say the type. The variables that point to things, they're not typed, even though underlying objects are typed. So I'll say this, get days. Now I could just inline this, of course, but let's go ahead and just show you how it works. All right. Now with PyCharm, I can hit Alt-Enter, and it'll create this function up here for me, which is pretty awesome. So let's go write that. Now this one I want to really compare and contrast this with C# for you. So what I would like to do is something that looks like this, a list of string, let's call this days, equals new list of string. So if I want to write that code in Python, here's what I say. I say days equals bracket bracket. Right? It looks like an array to C# guys, but that means list in Python. And in fact, I want to go over here and fill it up with some days. So let's see. I can duplicate that. All right, now I come over here and we can say, let's just say Monday, Tuesday, just abbreviate it like so. Got a few more. Friday, Saturday, and Sunday. Okay. Now, let's see. What I want to do is just return this. So when you say return days, right? No semicolons, no line endings. Now, technically, we don't really need this. I just wrote it like that to sort of simply introduce it. Now, how would this part look in C#? Remember, this would be public. This would be a list of string get days, like that. All right, just so you guys see how much simpler and more readable these things are. So here we've got our days, and the next thing I want to do is I want to loop over them. So we're going to use a for loop, but maybe not one that you guys are used to, more like a for each loop. So we'll say this. So report equals get random report. There, and we'll write that method in a minute. And then I'm going to do what would be a console write line for you .NET guys. This would be a print, and I would probably want to spell that. Let's say on curly 0, same sort of formatting. It will be curly 1, like this. And then we can say .format, and it'll be day, comma, report. Okay, looking good. Last thing to do is implement that method. So I want to create that one. And here what I want to do is I want to have some reports. Let's just call it weather. And like I had above, I'll just have a few sunny, lovely, and cold. Oops. Cold, okay? So that should be enough. And then I want to randomly pick one of those. So we'll say return weather. And I need to put something in here. So I can do this. Here's another cool PyCharm feature. I say random. And now that's actually like an external class that's not imported. So I can hit Alt-Enter and it'll say we're going to import this name as random. And notice at the top it put import random. So I'll say rand_int. Okay. And then in here I'm going to put some sort of start and end values. We'll say 0 to the length of weather. Now, one question I have to ask myself is, does this end get included or not? Because if it's not included, I want to leave this. But if it does, I need a -1 here. So I can actually go over here and say Control Q, and it'll actually pull up the documentation. Very cool PyCharm feature as well. Let me scroll down here. It says random number includes both endpoints. Okay, cool. So I better do -1. Also notice there's a few little formatting issues here, so I can say reformat that, hit a hotkey. There we go. So our app should be ready to go, except for it will not run the main by default. So if I try to run it, you'll see just nothing happens. Something will happen, but no output will be there. So I just process exited. So let's go down here and say, you know what, I really want to call main. And let's run that again. Excellent. So on Monday it's going to be cold, cold, lovely, sunny. We run it again, we'll get to different output. So besides defining classes, you guys are very much ready to sort of dig into the cool features from the .NET side of the world. Okay, one final comment here is when you import, like up here we saw import random, if somebody imports this library, this module that I wrote here, it's going to run main. So there's this trick you'll see all the time, if under name is under main, like so, then we want to run it. So that's sort of an import friendly way, and let's just run it one more time just to make sure things work. Yeah, so it works great. Okay, I see there's some questions. Dimitri, let me know if it's anything that is targeted to me, and if not, I'll just keep going. Okay, so you guys now know a little bit about Python, enough to appreciate the things we're going to talk about. And we got to go quick through some of these, and we'll dwell longer on others. Now, if somebody said, Michael, why are you a .NET developer? Why do you continue to use this language when there's other choices? .NET is one of the main languages I use along with Python. I'd put this list together. I would say, look, I think it's awesome that everything is an object. There's a common type system where there's a common base class. I think this concept of for each loops really makes a lot of the off by one and casting and indexing errors we often run into go away. That's great. Properties are awesome. Anonymous types. The ability to just say add reference, not use what like C style stuff does with like libs, headers, DLLs, static linking, all that kind of stuff. Just super easy, you know, add reference type stuff. NUGET, there's a bunch of things, so we're going to go through them here, so I don't really need to list them out for you, but there's many things in .NET that I think are, you know, reasons to love that environment and that language. What we're going to see is every single one of these features exists in Python. Okay, sometimes better, sometimes not as good. All right, so I already talked about IDEs a little bit. If you're in .NET, you're probably using Visual Studio almost, 99.9% of the time. You might be using Xamarin Studio for the few others that aren't. Okay, but over in Python, we've got PyCharm. And like I said, there's some others, but I think PyCharm stands head and shoulders above the others, so I won't go into the detail. Debugging, you'd like to be able to hit F5, F9, put breakpoints, step in, sort of change stuff live. Same thing with PyCharm. We could go over there and set breakpoints, debug into it, just like you guys know and love. So it's beautiful. Talked about everything as an object, right? The fact that even if I don't say it, when I define a class like this in C#, regardless of whether I put :object or I don't, the thing derives from object. And that gives us some common functionality that we can always work with. And the analogy isn't 100%, but in Python 3, everything derives from object as well. It doesn't gain as much base functionality, but still, the fact that you have this common base type you can always use is really handy. Okay. The next one we want to look at in more depth, is this idea of for each loops. So in C#, we've got anything that is IEnumerable here, we can go and write a for each loop over it. Okay, so you kind of saw that already in Python, but let me just make a separate bit here for you. Let's say new directory, some stuff for iteration here. Let's add a new file and call this loops or something like that. Again, you guys know who I am. So what we'll do is we'll define a variable of type numbers. We'll just put some like prime numbers or something in here, something like that, right? And in Python, we actually don't even have an index loop structure. You won't see anything like this. Int I equals 0, I less than da-da-da, right? There is no indexing style here. So we would say something for like n in nums, and then we can just print out, and maybe we'll do something like n equals something like that. So it all goes on one line. So if I run this one, you can see very nice, just like C#. Okay, well that's pretty cool. There are some tricks that you can do if you need the index. Let's change this for a minute. We can say enumerate. If you actually need the index back, you can use this enumerate. Whoops, if I can spell enumerate. There you go. Run this again. Whoops. If I put the V, didn't really need to change it, did I? There you go. You can actually get back something called a tuple, where the values are the second value and the indexes are the first. All right, so we could even write it like this if you wanted, index, comma, n, right? And you would get this back. And I won't show the index, but you can write it like this and do some nice stuff. So there's sort of the different ways you can work with the loops. Now let's move on to something more interesting. Suppose I want to create a class that's like a shopping cart or something. It's a collection of items, a collection of cart items. So let's define a class called cart item. And here's how you define a class, not super complicated, as you can see. So we want to basically have what would be a constructor. So we're going to have a under init method here, and it's going to take a couple of variables. It's going to have a name of the cart item and the price that we're going to pass in there. And I can use this cool PyCharm feature, Alt-Enter, and it will say add this as a field to this class. And of course it wraps it like that, which since I'm doing two, I don't need to do it this way. All right. So here we've got our cart item. And just so it's easier to print out, let me kind of do this override to string thing here and return this representation. So we'll return curly 0, dollar curly 1. Here's our price statement. So I can, if somebody asks for a representation of this, I'll say here's the self.name, self.price. And by the way, self is like this in C#, just so you all know. Okay, so there's our cart item. Now let's have a shopping cart class. And in here, we're going to again define an init method, and we'll have a set of items here, like so. Okay, and then we're going to have an add. In our add, it's going to take a cart item, let's say, and we'll just say self.items.append. That's how you insert stuff into lists in Python. Let's say cart item. Okay. Excellent. And let's just leave it with that for a minute. So we'll go and create some cart items. So we'll say cart, give it a little more room here. Cart equals shopping cart. Oops. So there's no new keyword in Python. You just sort of call it as if you were calling a constructor. No new keyword. Okay, so here we have our add method we wrote. And notice also we can get to our items. Maybe we want to make that private. We'll do something with that in a minute. Let's say cart item, and let's just add cart item. We'll just add a few things in here. Did I spell that? I called it car item. Not my intention. There we go. Okay, so we need to add the name. Let's just say we want to buy a CD, and the price of the CD will be $19.99. And we're going to buy a record. Let's make this a record. And again, I can loop over these things. So I could say something like this. I could say for item in cart.items. This is not the way we're going to keep it, but let's do this for a minute. Say print cart item. Excuse me. So let's go ahead and run that again. Oh, there we got that. And the other one is up here. That's right. I need some new lines. So let's put a few new lines in there. Here you go. So there's our two items that we added into our cart, right? So that's pretty cool, but exposing our items directly, not super good for encapsulation. Somebody could come over here and go .clear, we don't need any more items or whatever, right? Maybe we don't want to let them have access to that. So over in Python, I can go put a double underbar here, under items, and then if I go back to my thing and say dot, notice items is gone. Right, it's private. There's technically still ways to get to it, but you shouldn't, so I'm not going to show you how. It's no big deal. You guys could find it. But basically, it's intended to be private, and so we're not going to mess with it. And PyCharm does a good job of not showing us how we could access it. So if I try to run this, I'm going to get the same error you would get in .NET if you try to for each over something that's not iterable. It says it's not iterable. Crash. So we need to implement iteration. So in Python, in C#, here's how we implement iteration in our custom types. We derive from IEnumerable of some type. We have a couple of methods that define, get enumerator and each level. This is very, very similar. And see how much stuff there is just to say just iterate over the items. Let's see how we do that in Python. So we'll switch back over here. We're going to define what's called a magic method, another one like our under init, but this can be under iter. And I'm just going to say return self dot under items dot under iter, like so. That's it. Right? That's this bit right here is the equivalent of making your objects IEnumerable. And when you do that, there's all sorts of awesome stuff, just like in .NET, that opens up to you. So for example, in .NET, we can do LINQ against things that are IEnumerable. You'll see something similar here. All right, but let's go ahead and run this, and bam, it's back, just like it should be. Okay, so now we can have our encapsulation and iterate over it as well. So just take a look at the difference between the code on both of these sort of screens here. They're identical in terms of functionality and everything. What would you rather type? What would you rather read, right? This is sort of some of the really nice things about Python here. Okay. Another thing that really .NET and C# got right straight from the beginning in 2002 when they introduced it was the idea of properties. So here maybe our shopping cart wants to be able to have like a total price or subtotal or something like that, which is sort of the sum of the prices of the items. So we could write this in .NET, but what do we do in Python? Well, let's add a method over here for starters, okay? Let's say def total under price. And let's say we're define a total value equals 0. And then we're going to just for over our items, item in self dot under items. Say total plus equals item dot price. Return total. Okay. So down here, why is this unhappy? I think it's okay. Let's say we're just going to print total price is, put my $, curly 0. Let's make it 2 decimal places here. So dot format cart dot total price. Now notice this is a method. I'm just going to leave it that way for a minute. Let's run this, make sure I got it working. Total price is $37.98. Okay? That's not the idea of property. This is like a getter method. That's not what we want. But in Python, we have this something similar to attributes, and these are called decorators. And I can say at property. PyCharm lights it up nicely, colors it. And now if I go over here and I go back to IntelliSense, I say dot total price. And notice there's a little P right there. I don't know if you can see it, but it means property, like so. So now if I just leave it without calling the function, right, it's gone. And if I even try to call the function, it'll say cannot call the function float, right? Float is not executable, something like that, okay? So you have to treat it as a property. Very nice. All right, so in Python, we can do this too. And again, it's a lot less writing. Let's keep going. Something that was introduced in C#3 that was super awesome is this idea of anonymous types. Anonymous types don't make tons of sense on their own. They make a lot more sense when you think of them in the context of LINQ, and you've got like an object model and you want to do a projection from maybe a whole bunch of properties in an object down to just a few, or maybe some of them are computed and some are values and things like that. So we'll look at them in isolation, but think about using them in the context of LINQ, and back to that when we get to that as well. All right, so here we could just say var o equals new whatever, and the system will work with it, create it. We can say o.registered and o.id, and it knows what the values are and so on. So can we do this in Python? Well, almost. It turns out we need to enter a little bit of code here, which I'm going to rob from my slides. So just to save us some time. Okay, so let's go and add another folder called S4 anon, something like that. Let's add a Python class, a Python file. Call this non-object, and let's put that in there. Okay, so if we define this type, and I'll explain it in a minute, then we can do more or less exactly what we were able to do in .NET. So I can say create me a person or something like that. That's kind of what we had before. And I can say name colon Michael, and let's see, age colon, how old am I? I guess I'm 40 these days. So what we've created so far is a dictionary. That's our base type. And if I print out the person, you can see there's cool stuff here. Right? Of course, if I run the right one, sorry. Print out, here's my name and age, and I can even do things like print out, let's duplicate this line a little bit here. Let's say I can print out the name. That's cool. If I try this again, there's the name. But if I really try to sort of have full parity with what I was showing you, if I say .name, it's not going to like this. It's like, no, no, no. Dictionary has no thing called name. But if I use this guy, where we redefine what get and set attribute, basically field access means, is to go into the dictionary. Let's rewrite this. Let's say a non-person equals, and we'll say a non-object, and here we'll just say name equals Michael and age equals 40. And let's go back and try this again with our non-person. Here. And run it one more time. Here you go, look at that. I don't know what their age is, just say person.age. Okay, so this is not super interesting on its own, but when we get to talking about things like LINQ and databases and so on, it all of a sudden gets pretty interesting. Okay? So, one thing that's great about C#, anonymous, well, with the very slightest bit of changes, we have that in Python as well. Okay? Lambda expressions. Lambda expressions allow you to take what would be normal methods and sort of inline them into this in super concise form. So here I've got a method called find numbers, and what it does is you pass in some sort of test, a predicate, and it gives you a bunch of numbers, and all the ones which pass this test, well, they're returned. The ones who don't are omitted. And notice this, I can sort of define that. I say n goes to, that's how you read this, equals greater than, n goes to n mod 11 equals 0. So find me all the divisible by 11 numbers. How would we do this in Python? Okay, so let's go back, make another little section for you. All this code, by the way, will be available to you along the way. Okay, so let's have that function again, def get numbers, and it's going to take a limit. Yeah, limit is fine for now. And we'll say it's going to take a predicate. Okay, not the type, it's just the variable name. And what we'll do is we'll say for n in range of 0 to limit. Say, let's first start just by say returning n. Okay. And down here, what are we going to do? We're going to say, let's just grab this in a list. Go output equals list of get nums, and let's just do this for let's say 40, so it fits on the screen. And oh yeah, it needs null, so none in Python. We'll say print output. Okay, so let's run this and see what happens. Whoops, object int is not iterable. Sorry, yield. Okay, so there's our numbers. You can guess that it goes up to 40. And let's pass it a different test. Well, if I define another method up here like def divide by 11, and it's going to take a number, n, and it's going to return n mod 11 equal 0. Okay, so then we could pass this divide by 11 by name, just like you could in .NET. And of course, we're not testing it, so let's do this test here really quick. We'll say if a predicate of n, then we'll do this. All right, so here's our divisible by 11 numbers. But instead of doing this, let's go and do what you would do in C# as well. Let's actually pass something here. So I'd kind of like to have a lambda, and in C# it was, and goes to that. In Python it's not that. Instead you say this, you say lambda and colon. So express it's a lambda expression, and then this is your separator instead of the goes to. And let's just run it, but let me make it divisible by 10 just so you see a different output. There you go, 0, 10, 20, 30. Look how nice it is. Exactly the same as C# in terms of all of its glory. But again, less typing. So here's yet another thing that people often think is super special, about C#. Python has it in all of its glory. All right. Now, one of the really sort of crowning achievements of .NET, I think, in version 3 was this whole concept of LINQ. I can treat anything as if it's a database, even if it is not, right? If it implements IEnumerable, we can go and do whatever, treat it like a database, right? So here we can go, give me all the people where the age is greater than 30 in order by descending, and do this projection where we only store the name and the age, even though there might be 100 properties, okay? And if people comes from a database, well, then we do the query against the database. If it comes from MongoDB, a NoSQL database, it goes there. If it's in memory, it goes there. So Python has a very similar feature, actually, but you've got to separate the database version from the in-memory version. So let's look at the in-memory version. Okay. Create another directory. We'll call this under 6. Call it LINQ from your .NET perspective, if you will. Okay, so like so. So let's really quickly define another class, person. You guys should be getting good at this. Def under init. I'm going to have a name, age, and hobby. Let's do that. Use PyCharm to create do all the dirty work for us. Okay, great. So there's our person class. Let's create a list of them. Let's say people equals, and we create a list of a person, and let's see, the name will be Jeff, his age will be 50, and his hobby will be biking. Let's see, I guess I'll put myself in the mix. You guys already know how old I am. Go across. How about that for hobby? That's a good one. Okay, Sarah, 30, she does running. And Tony, he's 24, and he likes, what does he like? He likes jogging, which is like the wimpier version of running, I guess. And then last one we'll have Zoe, and she's only 12, and she likes TV. That's her hobby. Okay? So what I want to do, let's just print this out to make sure we got our people coming together. All right, let's run this. All right, so there's our, I guess I got to do the representation here really quick. Hold on. Return 0 is curly1 and likes curly2. Format self.name, self.age, self.hobby. Let me add, I'm going to make this one biking just so we can do a few more filtering things. Okay, let's go ahead and run this again. There you go. Each person, and we can even do sep equals \n. That do it for us? No. Not that way it won't. Okay, so here's our people. What we want to do is we want to write some sort of statement like we had before, like I would like to find all the bikers. Now I'd like to do this in some sort of like declarative fashion without looping and doing all this stuff, and just I'd like to express it. So very much like LINQ, we can say that in Python. So we would say first we sort of say the kind of the from, not from, we define the thing. We say p for p and people. And then we have an if. We say if p dot hobby is biking. Okay, and now let's go over here and let's say for B in bikers, print B. Okay, let's run this and see if this works. Look at that, excellent. Jeff is 50 and likes biking. Now we can also do projections. You saw in my example that we said, let's project from this larger object down to a smaller thing. So we can use our anonymous type. I can say for a non-object, which we already talked about, and I can import that at the top. That's why I put my underscores in my folders. So basically, so that would work. I can say, let's just make this a little bit different. Let's just make this name equals p.name, just to show you we can change this. And we'll say pastime. What do they do to pass the time? Well, p.hobby. That's what they do. Okay. Now when I do this, I've got to, basically this is the object I'm working on. So I got to do p.pastime. Let's see. I'm not sure actually. Let's find out. Yeah, sorry, hobby. Here we go. So we've got our people. We do our filter on them, and we can do a projection. The only thing we can't easily do that would sort of keep us in parity with LINQ is the ordering. So the sort, basically. So we need to say bikers.sort. And here we go key equals, and we can just say the item that we worked in. So this is going to be lambda. P goes to p dot. And here we want name, I suppose. So right now we have Jeff and Michael. And let me put them in a different order just so you'll see that we can actually sort something here. Okay, so let's run this again. All right, there's Michael and Jeff. Let's put the sort in here. Key equals, like so. Run it again. Here we go. Now we got Jeff and Michael, not Michael and Jeff. So we're sorting by this. Let's reformat the code to get rid of some of the warnings, okay? All right, so we're making our way through all these .NET features, and so far, it looks like Python has almost every one of these, including some of the really killer ones like Lambda expressions and for each loops and LINQ and so on. So you do have to reorder these. So here you can see that the where clause kind of goes to the end. The ordering has to be put outside if you're going to do it efficiently, not sorting the whole thing, just sorting the ones coming out of the list. And the projection goes in a different order, but basically, same thing. Another thing that's come out in the last few years in .NET that's made it awesome is NUGET. So NUGET allows us to go out and basically add reference to open source on the web. Okay, and it'll pull those down, and it'll keep them up to date, and so on. So here you can see we can either use the UI or this PowerShell command to download and add a reference to the MongoDB driver for C#. That's pretty cool. Well, Python has very, very similar things. Okay, so we can do the same thing, and PyCharm actually has a GUI for this as well. What's kind of surprising is if you look at how much content there is for .NET, there's like 18,000 packages. That's pretty awesome. Python has almost 40,000, more than twice as many, or maybe very close to twice as many. So if I come over here, I can go to my settings for this project. I go to my Python interpreter, and this is the one I have selected, and I can say, well, what do we need? Here's some stuff that's out of date, so maybe I want to update setup tool, so I can upgrade that. And you'll notice, maybe my screen is a little small here, but down at the bottom you see installing package setup tools. Okay, that was updated. Maybe I should upgrade this one, right? Maybe I want to use some MongoDB, so after this next one's done, after pip is upgraded, I go over here and say I want to install PyMongo. It's the default driver for MongoDB. Here's the version. I can pick a specific version, but I'll just say install that one. You see down here it's installing. Give it a moment. It's running some C extension compilation. It takes it a second. Okay, great. So now that's done. Let's go over here and go back to the top of any of these, and I can say import PyMongo. Boom, just like that. So this whole concept of package management is at least as rich in Python as it is in .NET, and is of course has long been around before .NET ever had NUGET. Okay, super nice. All right, we already saw this one. We saw that this is one of the really unknown features of C#, this yield return keyword for so-called generators, generator methods, allow you to sort of create IEnumerables efficiently using the yield return keyword. We already saw in our, which example was it? One of them, we were doing yield. This was our Lambda expression example. We can just say yield, and this will also generate a generator. And it only will generate, only execute this code as you process it, right? It sort of does lazy evaluation. So here's a really cool thing we could do for Fibonacci. So we have time. Yeah, we have a little bit more time. Is it 7? Sure. We'll call this generators. See how well I remember my Fibonacci sequence. So I can come over here and I can say define a function that returns the Fibonacci, Fibonacci, I think something like that. Probably misspelled still, sorry. Okay, so we can come over here and say, actually, I'd like to generate some numbers, and I could put a limit, but you'll see this could actually be infinite. And if you tried to do something like store these numbers and return a list, and the list was infinite, that's going to turn out badly in one way or another, either in time or in memory or something to that effect, okay? But what I can do is I can say define a couple of variables, current equals 0, next equals 1, and then I can say while true. That's kind of crazy and scary, but I'll say next, let's say current next equals next comma current plus next. It's pretty interesting. Oh, I want to change that because next is also a function I built in. Let's change that like so. Okay, and I'll say yield next, current rather, sorry. So let's go down here and call this function. Let's say for n in Fibonacci, if n is less than 200, let's say reverse it. If it's bigger than 200, we'll just break out of our loop. Break else print in, and let's have a new line character of just being a comma. Okay. Let's run this. Now here we're generating basically an infinite series, right? But we only execute it as we process it, and if we stop processing it, then it's all good. So let's just go down here. Yeah, that should be fine. Run. Look at that. Pretty amazing, huh? So yield keyword, very nice for generating these super efficient things. And so I could say even, I could go print generating plus string of current, something like that. Actually, it's probably going to look wrong unless I do it this way. And you'll see it's actually only going through the loop for each time we iterate over it, okay? So, very cool. I've got just a couple more minutes. Let me go through the slides really quick and see what else we have. So, as .NET developers, we know ASP.NET MVC and the .NET sort of ASP.NET world is pretty awesome. There's a lot of cool things there. In Python, we have a ton of really interesting web frameworks as well, MVC-oriented. Pyramid is the one I'm currently working most with. Flask is also interesting. It seems to have a lot of enthusiasm, a lot of people I know that are really bright are doing stuff with it. It doesn't necessarily have as many big name users of it. Django is also kind of a really major one in the Python world. So you've got a lot of web choices. In .NET, we have the sort of main ORM is Entity Framework. Well, in Python, there's something called SQL Alchemy, and it's just as awesome as Entity Framework. If you know Entity Framework well, think of Entity Framework code first, all the cool stuff you can do there. SQL Alchemy is sort of that for Python. Very nice. We talked about Python is typically interpreted. All the code you saw me write was running on CPython, and so that means it's interpreted, but it can be JIT compiled. There's PyPy, which is pretty awesome. It's like a JIT compiled version. In some measures, it's 5 times faster than Python. A little more restrictive on what you can do, but it's 100% Python, doesn't go into like C extensions and stuff. There's also IronPython, which is probably most interesting to .NET people in that this is a way to take regular Python code and run it on the .NET framework and the CLR, which is pretty awesome. And you can expose your Python types to C# libraries, and you can expose C# libraries to your Python code. Very nice. Jython is that same thing for Java developers, right? Same thing, but on the JVM. GUI designers, we've got WPF, Windows Forms to a lesser degree in .NET. There's PyQt, the Qt framework, and a lot of cool stuff you can do over here with PyQt and PySide. It's not quite as awesome as WPF, but still you can build cross-platform GUIs in Python, and that's pretty awesome. Okay, so there you guys have it. That's Python for the C# developer. Hopefully, you haven't entirely learned Python from what I've shown you, right? Python is a journey, like all languages, and there's a lot of subtleties and experience you need to gain. But hopefully, I've shown you enough to encourage you to dig into these things, right? So we saw so many parts of .NET are awesome, and thinking of like working in another language, you're like, well, there's no way I could give up LINQ. There's no way I could give up like properties. You don't have to if you do Python. All these things are really, there's many of these equivalent features. Sometimes they're even nicer, right? Like making things iterable and so on. Super easy. And you saw me using PyCharm. Super good IDE. I don't miss Visual Studio at all. I mean, imagine the guys who built ReSharper, same guys who built PyCharm, at least in terms of the company. Imagine they went out and built their very own Visual Studio. How awesome that would be? That's PyCharm for Python, right? Excellent. So, final call to action. You guys should go download PyCharm and try it if you haven't. There's a 30-day trial. There's a community edition. They've done a lot of stuff to make that accessible. So that's cool. Follow me online. Here's my Twitter account and my blog. And I also have a Python course at Developmentor. So if you guys want a 4-day training course, reach out to us at develop.com. Otherwise, Dimitri, I'm going to kick it back to you and see if there's any questions.
Okay, great. Actually, we have a bunch of questions already.
Okay, fantastic.
The first question is from Sin. He asks, I use a lot of camel case naming in C# and noticed that your Python use a lot of lowercase underscores combinations. Is that
Yes.
widely used syntax, and are there any restrictions you have come across?
There's not really restrictions that I know of. It is widely used. I could write get numbers, and that might be okay. You notice that PyCharm, whoops, actually, sorry, I could do it up here. PyCharm will say, this word is misspelled, so that's kind of funky. If I do something like he was proposing, like get numbers, you'll notice that this does not conform to what's called the PEP 8 convention, so the sort of agreed upon convention for Python code standards. So uppercase names like this, not so much. If this was Java, you might write that. But again, same problem. It's like, what should we rename this to? Something other than that, right? So if you want a separator, underscore is the common separator. But the separator itself is not necessarily required. Okay.
Okay, great. The next question is, how much faster would Python be in comparison to .NET or C# when running large applications?
So that's a super interesting question, and it really depends. Like if you take this bit of code right here and you run it against C#, I suspect that C# will probably crush it. It'll just blow it away. That said, really major applications have been written on Python, and most major applications, the code that you're writing is not really where the latency is. It's in talking to a database or waiting on a web stack to process something. Let me pull up an example here from something I was working on. Do I have it around? Oh, excellent. So I was working on a MongoDB web example in Pyramid. Okay, so if you look at how fast this code runs, let me just run it here. Hold on, it's refreshing its index at the bottom. And that thing gets it, I can run it. Okay, so let me run this for you. And the reason I pulled this up is this is not the best, I suppose. What is going on with it? I don't think I got to reconfigure it. Anyway, basically, in order to go from, I don't want to take too much time and make room for other questions. In order to process a request from the web browser, go turn this into a query that goes to MongoDB, process the query in MongoDB, get it back, serialize it, send it through a template, and get it back out, is around 1.5 milliseconds per request, right? And almost all the latency you would expect is going to talk to a database. So in large applications, I think it's going to perform fine. I mean, there's definitely some really major applications written on Pyramid. DropBox, for example, Pinterest. I'm not sure if that's Django or Pyramid. Maybe you know, Dimitri. But there's some of the really large sites, like Discus is one of with one of those little plug comments into your blog's service. They have 8 billion page views per month, and they're running on Django, which is Python, one of the Python web stacks. So I think you'll be fine in real applications. If you're doing scientific stuff, that's the one case where you might really care, but you could check out like NumPy and SciPy and those sorts of things. Right here, scipy.org. Right, so if you're doing scientific stuff, you'd want to look at probably the enhancements that these guys have. Okay, next one, Dimitri.
Okay, there are a bunch of questions about the settings file. The first question is, can you change the syntax rules like in Eclipse or Visual Studio using a settings file? And the second was about the author sign that everybody noticed that appears on each file.
Sure, so let me take it in reverse order. If I go to the settings, I can come down here. There's a template.
It's file and code templates.
Yeah, file and code templates. There it is. Yes. If I go to Python, Python script, this is what it is. And if I delete that, it doesn't show up. If I put more, I could have like notes or whatever. And when I create a new file, whatever happens, this will show up.
Okay, cool. So and what's going on with all the double scores? Double underscores.
The double underscores. Yeah, okay, so double underscores mean certain things in Python. It indicates, like in this case, this is a magic method, right? So this is sort of a little bit the common type system. So all these types have, if I say under, there's a bunch of different predefined methods that if you implement it, gives your object special behavior that the Python runtime knows about. So I can implement equality. I can implement, this is like the in operator. This is like the destructor. Delete is remove, property leave, things like that. So basically the under on the method names tells you that it that it's one of these built-ins. Now let me go back here. On one of these, was it Lambdas? No, the LINQ, I think. No, it was iteration here. On this one, I said I'm going to name my variable under items, and that just indicates to Python like, hey, this should be private, so kind of try to hide it. There's technically a way to look at what's in here. If I say if I print dir of cart, and let me run this again. Here you can actually look at all the things that here you can actually see. I said I wouldn't show you, but I'm showing you anyway. It's fine. This is actually the variable. It sort of does this name mangling, and then PyCharm knows to hide it from you. So it's being used in a couple of ways.
Okay. Could you tell us more about the lack of static typing in Python?
The lack of static typing, sure.
Yeah.
So let me go to the class. It's probably the best example, which I believe was in LINQ. So here's one. I guess I could have done it from the loops as well. But here's a class that we're defining. Okay. Now in .NET, when you type something like this, you say class and it has methods and it has properties, you're basically defining a structure that is later used at runtime to construct things. When you say this in Python, you're basically executing some statements. And this will create an object with this thing called under dictionary. So if I say print, let's do it on one of our people, say P1 equals, let's just grab this one. And I say print P1 dot under dictionary. Let's run that. Go up. Here you can see that the age and the name are really, when you say self.age, self.name, it just stuffs this into like this inner dictionary. And there's a similar one for the methods itself. So if I had a method like, get age or whatever, right? It sort of constructs the class, the shape of the class, rather than sort of defining the structure. So you can think of this code as actually executing to define the fields and to define the methods. Okay. And then there's a person object, which then this is its own class, and then when you execute it, it sort of instantiates one of these using its defaults. In that sense, it's a little bit like JavaScript with the prototypical inheritance, which is a little different than the static inheritance of C#. Make sense? Dimitri, anything to add?
Okay, yeah. A few more quick questions. The first one is about Python version. Does Python 2.7 also have support to Lambda expressions and LINQ equivalent syntax like Python 3.3?
So that is a great question. I don't do that much with Python 2.7. Many of the features are backported. We can find out really quick. Oops. P2.7. Okay. And let's go to our settings. I believe a lot of the features have been ported backwards. For some reason, this might not be the best time to do this. Ooh, I don't have Python 2.7 installed. Sorry. I had it a little while ago. Okay, I'm sorry. I guess I can't show you. Honestly, I don't know. But I can tell you that many of the features that were introduced in Python 3 were backported into it. So it's very, very possible, but honestly, I don't know off the top of my head. Sorry.
Okay. We have a number of questions which are actually the same. When would you use C# over Python?
That's a good question.
So,
to be honest, I struggle. Yeah, sure. I struggle with that a little bit myself. Like when I write a lot of Python and I see how simple it is, I really don't like going back to .NET. I'm like, oh, there's so much stuff I got to do to just say the same thing, But when I'm working on really large projects, the ability to make a change and see the code sort of fail to compile throughout the whole thing is really nice. So I'm a little bit torn. Like, I guess a decent answer might be the bigger the project, the more static typing will help you. But at the same time, really large, successful things are built on Python. And people who love Python would be happier developing Python than C# probably anyway. So I would look at the team that you're working with. If you have a bunch of guys who don't really know Python and they all know C#, it's probably better to stick with C#. If people are looking to try something new and some of the features of Python seem really neat for you, then consider going with Python. But I don't think that you can't build applications and large applications in one or the other or something like that, because both languages have some really big examples of amazing things built with them.
Okay. Could you briefly talk about multi-threading and libraries in Python?
Sure. So there is a multi-threaded library for CPython, and you can kick off other threads. But CPython is probably not your best choice if you're really interested in doing multi-threading. So you have two choices. If parallelism is super paramount to you and super important, there's two alternatives. Okay, one is stackless Python. Okay, So stackless Python is another implementation like PyPy or IronPython or so on that is really built to really leverage sort of lightweight threading scenarios on Python. Microthreads, channels, scheduling, all that kind of stuff. So if threading is super important to you, check out that. I guess you could use IronPython or Jython as well and follow it into whatever .NET and Java do. The other one is things like Twisted Python. So Twisted and some of the other related ones, I just saw Guido Van Rossum talking about something else, and I'm trying to remember what it was. Maybe Dimitri, But basically, there's something similar to what you can do with Node.js, where you sort of make everything asynchronous, non-blocking sort of calls. Okay, so there's libraries like Twisted that would not exactly be threading, but sort of would accomplish the same goals of parallelism that you're looking for, potentially.
Okay, good. Actually, this was the last question since we are running out of time.
Okay,
yeah,
sounds good.
Everybody, really don't worry if we haven't answered your questions. There are still plenty of them unanswered, so we will answer them directly by email in upcoming days. So just stay tuned. Now I'd like to thank Michael for his presentation. It was really cool. Thank you, Michael.
Yeah,
and
thank
now,
you. And thanks everyone for coming.
And now I would like to switch back to my screen to proceed with some additional information. Okay, show my screen. Well, if you would like to get more information on PyCharm, you should definitely go to jetbrains.com/PyCharm. This is our product site with a ton of information on it. We'll be happy to get any feedback on this webinar or about anything concerning PyCharm, so please feel free to send your feedback to me directly at dmitry.filipov@jetbrains.com or file any issue or feature request to our public issue tracker at utrack.jetbrains.com. Please check our PyCharm blog. We post there all information around PyCharm, like releases, upcoming events, or features and tutorials announcements. So, for example, the recording of this webinar will be announced there in a few days. We'll also provide some additional links and information from Michael's presentation over there. For additional information on PyCharm, please visit our public complaint space. You should be able to find PyCharm space on the dashboard, so there you will be fine. You will be fine tutorials, links to screencasts, and other stuff. If you would like to learn even more, please follow us on Twitter to learn product tips and get latest updates. So, thanks everybody for making this webinar successful. Thanks for watching. Have a nice day or evening. Now the webinar is over. Develop with pleasure. Bye-bye.